Hey everyone, so today we're going to be looking at this cool security camera effect in Unreal. This is using geometry script, making custom meshes. You can see it works at different angles, works different positions. As always, it is one way of doing a security camera effect, not the only way by far. Could be the one for you, and it's pretty versatile. You can actually do a lot of stuff with it. It's also relatively easy to do. There's really not a lot of complex stuff needing to be done here. Okay, so as always, first thing we're going to need to make a new project. I'm going to use the top-down template here. This gives you a sort of nice view, and because I'm going to do this for this demo on that sort of XY plane rather than the sort of XZ or YZ plane, it's going to work quite nicely. You can, of course, use any one you want. Let's call this Vision Cone Video, because obviously the Vision Cone one I used already. And let's hit create. Okay, now our project is opened and we want to use geometry script. So before we do anything else, we're going to go into plugins. I'm going to type geometry script. There it is, geometry script. Yes, we're aware this is a beta. I'm going to restart. Okay, now we're back again in the engine and we're ready to get going. Okay, so before we get into our actual building our actual system in Unreal, let's talk through what it actually means to make a security camera so that we know the reason behind what we're doing. So what we want is we want our camera object and we want it to look out in a direction and we want it to see things within an arc. Okay, so we've got a vision arc here. And this is our vision arc. This is the angle of our vision arc. And then what we want is within this, if something enters into this, it's going to be able to see all of this space here, and it's going to not be able to see this space here. Okay, that's a key thing. It cannot see this space here. So ordinarily you could make this mesh and then you could use an overlap to test if something's come in here, but then if something overlaps here behind it, it's also going to technically see it. So what we need to do is you think this through logically. This is projecting out from here and it's seeing only the first thing that it hits. So what we actually want is for this to project outward multiple times, like this. And we want to check down these lines to see if we hit anything. And we only actually want to draw this here, like that. So that's what we're actually doing. So what we need is we need a vision arc here. We need this space and we need this distance. Okay, so that's the three key things that we're going to give it. Now there's one other thing I want to mention, which is you could calculate this by saying, well, this is my vision arc and we're going to divide it into X number of pieces. The problem with this is that if you make the vision arc, if you say, we're going to do this in like 6, I'm really bad at doing stuff like this, so like that, so this was 1, 2, or however many that is. Let's see, that's 1, 2, 3, 4, 5. Then if you make a bigger arc, what happens is doing the same number of pieces, you're going to end up with bigger sections, and bigger sections mean more chance that things not going to be seen. So you're going to lose the fidelity of the scanning. So that's why I think we want to specify the full vision arc, and then we want to specify the size of this rather than the number of these. Okay, because that means that if you then make bigger vision arcs, cameras that can see further, you're not going to lose the fidelity of it. You're going to change the fidelity of the vision. Okay, So we're back in the editor. So let's right click. Let's make a blueprint class. I'm going to say actor. I'm going to say BP underscore vision cone. You can call it security camera. You can call it whatever you want. I'm going to double click on this. Let's dock this in our window so we can still see it. Now, we actually want, let's drop this into the world right away. Okay, now we actually want this to appear, the vision cone to appear in the editor. Okay, so the construction script will run in the editor, the event graph will not. So let's start here. And what I'm going to do is I'm actually going to add the component through the blueprints rather. I could go here and say add a dynamic mesh. But I'm thinking about flexibility here, and I think in the future I might want to make this a component that gets added to something. So for the sake of that, I am going to add component by add a dynamic mesh component here. Now, for the record, if you were making this as a component, you'd probably have to get the owner of the component and then add component by class, but you'd still do roughly the same thing. I'm going to promote this to a variable so that we can access it. Let's say dynamic mesh component. And then if you followed my other video, you probably know where we're going. Let's get the mesh from this. And then promote that so that we can still access that, because you don't want to have to keep getting stuff over and over again. We're going to say dynamic mesh. Okay, so we've got access to these things. Now, we know, I'm going to add a sequence just so we can keep things structured in a way that you can see things, and let's add comments to keep things neat and tidy. So generate dynamic mesh components and store. Let's move this up a little bit. Now, we do want to do a series of traces, but before we do that, just to make sure that our dynamic mesh is working, let's try adding a polygon to it. So we take our dynamic mesh and I'm going to do append. So append is how you add boxes, toruses, curved stairs, all sorts of things. We want to just do a single polygon. So we're going to do this triangulated polygon. This is a fun one to play around with. Now the polygon is going to be flat, so it takes two-dimensional vertices. We're going to make an array of these. And what you need to do here is you need to picture what we're building here. So what we're doing here is we're making a polygon, and by doing that, what we're doing is defining points in space, and the order in which we define those points in space will define the way that our polygon's drawn. So you have to be kind of careful. So like if we were drawing a square and we went to opposing corners like this, in that order, then you're going to get this sort of bow tie shape like that rather than a square. Now it's pretty easy for us right now. What we want to do is we want to make a triangle like that. So that's not too difficult. Think about what that means if we were to draw a graph or draw this on graph paper. The only thing is you got to remember this is 0. Okay, we want it to be centered around the middle of this thing. So the first thing we do is 0. Next thing, we want to go along and we want to go up. So let's just put in, for the sake of just testing stuff, we're going to put in 100 and we're going to put in 50. And then we're going to put in 100 and then we're going to put in minus 50. So we're going to go 0, we're going to go along 100 and up 50. And then we're going to go along 100 and down 50. And it's going to go bing, bing, bash. And we should get a triangle. Okay, so compile. I'm also going to take the dynamic mesh component and I'm going to set a material because it sometimes has a little difficulty drawing stuff if it doesn't know what material it's supposed to use. For now, I'm just going to use the proc grid material here. Okay, so now you can see we have this little triangle here. And it's not going to do anything fun, you know, it just kind of cuts into things because it's just a triangle. But what we've done is we've proven that we can indeed draw a triangle. And we can draw a triangle using a list of points. So the next thing we need to do is we need to get all of the points. You remember when we talked about what this was before, we said we want to take our point and we want to draw a bunch of lines. And this is where the variables that we talked about come in. So let's make our variables. We know we're going to make them floats. We know we want a vision arc. Let's expose that. We know we want a division of that vision arc. I'm going to call that the test vision arc. Remember, we could do a number here for how many times we're going to do the test, but this way, if we do it based on the size, we keep the fidelity of the scanning even when we make larger arcs. And then we're going to do vision length, which is how far we can look. So let's compile that. Let's put in some default values here. Now what I'm going to do is I'm going to deliberately put in values here that are not going to divide neatly for the arcs so that I can make sure that it's actually working properly. I put it to about 500, that's a good long vision. And we know that we're going to want to do that scanning multiple times. It's going to be something we repeat over and over. It's probably going to be used outside the construction script. So I'm going to make a function. I'm going to call that function do line traces. And what we're going to do is first we're going to take our vision arc. So we've got to figure out how many times we've got to line trace. So we divide the vision arc by the test vision arc. Now, like I said, that's not going to divide evenly. So what to do is make sure that we definitely do it the right number of times, we're going to round up. Now, you might be, if you're smart, you might have figured out that's going to mean we're going to do this one too many times quite often. Yes, we're going to fix for that later on. So now we need to do a for loop, not a for each loop, but just a regular old for loop. Starting at 0, we're going to do it this number of times. And we're just going to do a line trace by channel. There we go. Now, line trace by channel, we're going to start from the origin of our actor. So let's get our actor location. And we are going to end. So we want to go forward and we want to rotate forward by the appropriate amount to get the arc that we want. So let's get the actor forward vector. And that is a vector of length 1 in the direction that the actor is facing. And what we want is a vector of length, vision length, in the direction the actor is facing. So all we need to do is multiply that by the vision length float, and now we have effectively a vector that's going to go straight out in the direction the actor is facing to the length of vision length. But that's not all, because we want to do this in an arc that gets bigger as we go. So what we want to do is we're going to multiply. We're going to take the index. So every time we go through this, the index is going to go up. It's going to start at 0 and go up until this ceiling value here. And we're going to multiply that by the vision test arc. Now, of course, we said we're going to go too far here most of the time because of this. So we're going to clamp this float The minimum we want it to be is the value that we found, because we only ever really want to clamp it at the top end. And the maximum it can be is vision arc, so it will never be larger than the total vision arc. And we want to take this forward vector, move this over because we need a little more space for our calculation here. We want to rotate this vector, and we know that we're going to rotate this up around the up vector, like the vector that goes straight up is here. That's the pillar that we're going to twist around. If you want a reminder of that, it's here. That's the Z axis. So let's rotate this. Got all these different rotates here. We want rotate vector around axis because we've got an angle in degrees here, and the axis we want is up on Z. Okay, that gives us this. Now this is world space coordinates for our line trace, so we need to take our actor position and then we add this onto here. Now, in order to test this, I'm going to change the draw debug to for one frame. Because we're doing all the stuff we've done up until now in the construction script here, that's going to run once every time the thing needs updated. We want to be able to see this all the time. So what I'm going to do is on event tick, I'm going to take this out. It's going to say do line traces on event tick. Now when I go in here and I press play, we can see our line traces happening. Okay, but they're not centered. They're going, and that's because this is not rotated straight forward. That's a straight actor forward, and then this is all rotated around here. So that's not what we want. We want this to be centered. So what does it mean to be centered? Well, if straight forward is down the middle here, then what's on either side, or what should be on either side, is half of our vision arc. So all we've got to do is go back here, go into our do line traces function, and let's move some stuff over. And where we're creating this angle, we're going to take our vision arc again, we're going to divide this by 2, okay, and we're going to subtract that from here. So when it is in the first half of its vision arc, it's going to be negative, and then it's going to become positive. You do that, and now we have them centered on here. So now all we have to do is draw our polygon based on this point, these points here. So we need to store all this information and do stuff with it. And the fun thing about functions is functions can have outputs. So what we're going to do is we're going to add an output to this function of hit results. So you have hit result. There we go. Let's call it hit results. You see it's made a return node for us here. So once we're finished, return and spit the hit results back out. Let's make this an array because we need multiple of them. Now we need to calculate what this should be. So we also need an array within this function. So let's add a variable here. Same thing, hit result. Make it an array. We're going to call it local hit results. And what we want to do is every time we do a line trace, we want to add that line trace to this. Now we don't need to zero this array, clear this array, because this array is a local variable, so it's only going to exist as long as the function exists, and it will get restarted every time you run the function. And then we take this array and we just return it out here. From there we go back to our construction script, and what we want to do is in our construction script we want to do our line traces. Now the problem is this gives us hit results and we need polygon vertices. So when you hover over these, you can see this is array of hit result structures, and this is array of vector 2D structures. So we need to convert our hit results into two-dimensional vertices. I'm going to do that with another function. So I'm going to call this hit results to 2D vertices. I'm doing these in separate functions. This is for what we call sort of recyclability, portability, because we might want to change the way that this works later on. So having the discrete steps as discrete functions that we can maybe swap out or maybe make alterations to makes that process a bit easier. Now, we know that this is taking in hit results and putting out 2D vertices. So let's add an input array of hit results. We'll call this hit results. And an output array of vector 2D. Okay, so an array of vector 2Ds. We'll just call these 2D vertices. Now, we want to run logic for every hit result that we get. So that's a for each loop. So drag off hit results for each loop. This gives us a single hit result to look at for each loop. Now, a hit result is, if you hover over it, you can see it's hit result structure. So a structure, it's a struct, it's a type of variable that contains a set bunch of other variables. If we split this pin, you can see all the stuff that we've got here. So what we want to do is we want to output 2D, an array of 2D vertices. So again, so that we can track this, we're going to make a local vector, vector 2D, there we go. I'm going to call this local 2D vectors, and I'm going to take this return node because we already know what's going to happen here. When we're finished with this loop, we're going to return these 2D vectors. So how do we get these 2D vectors? What do we add to our local array? So we're going to add something every time. Now, what we want is, if this was a blocking hit, it's going to be a location here. And if it's not a blocking hit, we just want to get the endpoint of the trace. So we know we're going to have, both of these are vectors. We know it's going to be one of these two vectors here. So we're going to break that vector apart. And if I split the vector 2D and we only take the x and y, but which vector do we use? Well, we want to select one of those two vectors. And if you say select vector, you have a Boolean value down here that says pick A. So let's take blocking hit up here. So this will tell us if something in the hit result was actually hit. If something was actually hit, pick A, which is the location of the element that was hit. If nothing was hit, it's B, which is the trace end. Okay? So for every hit point, pick the, if it was a hit, pick the location. If it wasn't, pick the end. Break that vector apart, take the x and y and add that to the x and y of an entry in local 2D vectors, and then return local 2D vectors. Now, this isn't actually altering anything or performing any function. It's just working with data. So what we can do is we can call this a pure function. And that means when I go back here, go into the construction script, and I drag this out, you'll see it doesn't have an executive pin. It's just about processing. So we process the hit results into 2D vertices, and we do that. So we're doing our line traces, we're appending that as a polygon, setting the material. What does that look like? Well, not right. So why is that over there? Well, that is because if we go back to do line traces, this is outputting, these are world space coordinates, and then it outputs world space coordinates. So first thing we have to do is we have to change this. What that means is that is a coordinate in all of world space. That is a coordinate within the level. And when we're drawing our polygon, we're drawing it locally. Okay, we're using local coordinates relative to 0, 0 of this. So we need to change this value here, which is a world space value, into a local space value local to our current actor. And there is a node for this. It's called inverse transform. So if you were to transform a location to world space, you would use transform location. We're going to go the other way, so we're going to call it an inverse transform location. And it's inverse because we're going to use the world space transform of our actor. So we say actor transform. Okay, if you have this actor transform here, you can actually split apart and transform and see that it's a location, rotation, and scale. If you applied that to a localized vector, it would become the world vector, and we're going to apply this in the opposite to turn a world vector into a local vector. So inverse transform location. Now, there we go. So one step forward, and you can see as I drag it around, you can see the line traces happening. Now, it still doesn't look right, and that's because we have fed it all of the endpoints. And so it's drawing a polygon using all the endpoints, and you can see the flat end here where it's connecting the first point and last point. So what we need to do is add a 0 point at the start. So get our local 2D local vectors here. I'm just going to do this in the 2D vertices array. Now, to be honest, in terms of flexibility, this might not be the best solution. You might want to add this separately somewhere else. But for what we're doing right now, that works. Now, what's really cool about this is now you can see it gets chopped. Okay, so we're almost already there. It's all working in the construction script, but it's not working at real time. It's not actually doing anything at real time. So there's one thing I want to do for test purposes, and this is just heading off a problem that I know you're going to have later on, which is find your character. Now, in my case, I used the top-down template, so it's the top-down blueprints and character. And if we go to this character, you'll notice that in the capsule component, we're going to go down to collision, the preset for pawn ignores the visibility channel. And this, well, this might have a reason, this might have purposes. Okay, so this is the kind of thing that you have to be careful of what you want to do for your project. You might have a reason why you might not want the main character to block vision. I don't have any restrictions here, so I'm just going to go ahead and change the collision on the capsule component. So I'm going to say custom, I'm going to block, and I'm using the capsule component because the capsule gives us a really nice solid thing. You can use the mesh for a bit more fidelity, but it's a little trickier. It's easier to see the capsule component collision. So let's go back to this here. And what we want to do is we just want to recreate essentially what we did here. Only we don't want to keep appending polygons to our mesh. So what we're going to do is we're going to do our line traces, and then we're going to take our dynamic mesh and we're going to reset it to nothing. And then we're going to take our hit results, we're going to change them to 2D vertices, and you know what, I'm just going to go in here and I'm going to grab this and Control C and Control V, and I'm going to connect this target mesh up here, connect these vertices up here, and now I run this, there we go. And it's pretty much working. That's pretty much it. The one thing, let's take off, because it's really, really horrible to look at. Let's take off our debug on our line traces. Now the one thing is that this is kind of what we would call it's performance heavy. You know, it's rebuilding this mesh every single frame, no matter what. And if you think about it, we're gathering a bunch of test data here that we can use to determine if this mesh actually needs redrawn or not. So the condition under which we want to redraw it is if something has changed. So what we want to do is we want to check if this line trace result has changed. And we check if it's changed by looking at what it was like the time before. If you think about this, when we first run this, we're not going to have anything to check against. So let's first run do line traces on begin play. And then we're going to take that output, we're going to promote it to a variable, and I'm going to call this last hit results. And then what I'm going to do is, because we're going to be working with the output of this function, and we don't want to have to keep calling the function every time we do it, I'm going to promote this to a variable as well. I'm going to call this new hit results. And I'm going to break this for now. And we only want to run this part if the new hit results are not identical. So I'm going to say if the hit results are identical to last hit results, so it puts a boolean, I'm going to say branch, and then we connect this to the false line here. And just to test this, on true, I'm going to print a string and say not redrawing. Of course, I broke this a minute ago just to move it around. So we want to take new hit results, and we want to place that there. And then we also want to make sure that we update last hit results. And we only really need to do that if things have changed. So over here we go set last hit results to new hit results. So not redrawing, and then we go in here, and if I walk around a bit, you'll see it stops printing, and then it starts printing, and it starts printing, starts printing. So we've saved ourselves a little performance cycle there. And that's it. So that is how you make this vision cone. Loads of stuff you can do with this. It will work at various angles. So if I take this, there's one thing to watch out for, which is actually show you one little thing. So just to prove this is working at different angles, there you go. If I now go here, watch this. Ugh, it stutters horribly when you collide with the endpoint. This is a classic kind of problem. If you think about what's happening, like the closer in you get here, the smaller it's drawing things, till eventually it's drawing things so small that it starts to struggle. This is a sort of classic case of just don't do that then. So if you go here and you add a sphere to this point here, and the sphere by default has block all dynamic on it, and now we can't do that, so we just keep the player from causing that problem. There's a minor issue that if I try an alt drag, you see they are going to overlap in the editor, so you're going to get this massive stutter here with them. Once that stutter is gone, it's fine. You know, it's just because when they're really close to each other and they overlap, they create the same problem there. You know, I can live with that personally. You know, if it's an issue for you, then you know you can move the stuff off the construction script, or you can find other ways of getting around that. Other things you can do, because you are checking on do line trace for objects, you have a boolean here, so you could put a Boolean value here, set it to false, and then if you find a blocking hit, set it to true, and then return that Boolean here, and then now do line traces would tell you, give you a Boolean for when you've hit something. You could use that to detect something, and you could then take that and apply logic so the vision cone can speak to another object, open a door, sound an alarm, whatever. You could take this, you can put it into a component rather than its own blueprint, and then you could add it to an actor so it can be then tied into a socket on their head. There's 101 cool things that you can do with this. So that's it. I'm excited to see what you guys can do with this. Hope this helps someone out there. If it does, hit a like and subscribe, give me a comment, let me see what you did, and yeah, just have fun, guys.